So today we are looking at solving one-step and two-step equations. Our learning targets today are that we will be able to solve one-step equations and that we will be able to solve two-step equations. The standard is solve linear equations in one variable. So first of all, we want to identify an equation that is two expressions separated by an equal sign. Okay, a solution is a value that makes the equation true. Or it could be values. Okay, inverse operation, the operation that will undo another operation. And reciprocal is one number of a pair of numbers with a product of one. So one number with a pair of numbers with a product of one. One number of a pair of numbers that have a product of one. Okay, so for example, we would have 1/2 and 2 over 1, or 1/2 and 2 would be reciprocals. 1/2 and 2 are reciprocals. 3/4 and 4/3 are reciprocals. Okay. 5 and 1/5 are reciprocals. And I can write that as a 5, or I can write it as 5 over 1. Okay, so 5 and 1/5, those are reciprocals. The inverse of addition is subtraction. The inverse of subtraction is addition. The inverse of multiplication is division. The inverse of division is multiplication. The inverse of multiplication of a fraction, so if we want to do the opposite of multiplying by a fraction, we divide by its reciprocal. All right, and then just a review of our order of operations pyramid. Okay, so when we are evaluating, so we're finding the value, we're just taking a problem with no variables in it, and we're just working it through to get a numerical answer. Okay, so this is evaluating. Okay. And we do, PEMDAS, parentheses, all of our grouping symbols actually, then exponents, then multiply, divide, left to right, add, subtract, left to right. When we are solving, so we're solving for X, okay, or Y or Z or whatever our variable is. Here, when we're solving, we need to follow the order of operations in reverse. So we are working backwards to solve for X. Okay, it's kind of like when you lose something and you retrace your steps. What was I doing before this? What was I doing before that? Okay, that is how we solve. So I want you to draw an arrow going in the opposite direction. Okay, and you are solving, you work from the bottom up. Okay, so you're doing the order of operations in reverse. Let's switch to a different pen. Okay, next page. Okay, so next we're going to do some practice with 1 and 2-step equations. And at the top of this page, you can either make a sketch of the order of operations pyramid, or I'm going to write PEMDAS. And I know that that P will include other grouping symbols besides parentheses. And then when we're solving, we're working backwards, okay? And while you're still learning how to use that order of operations in reverse to solve, I would recommend that you write that on each of the problems when you get to the 2-step equations at least. Now, I know that it's really tempting to just do these in your head and work backwards in your head, but I'm going to challenge you to make sure that you're showing your work, because these are very simple equations. It's still September. These are going to get difficult they're going to get more difficult quickly, and we need to be solid with how do we work with the order of operations in reverse now, so that you understand the concept while we have easy problems. That way, when we get to multi-step questions that might have 6 or 7 steps in them, you understand how to use that order of operations in reverse. Okay, so the first thing we're going to do, we're not going to do parentheses and exponents, multiply, divide, then add, subtract. We're going to start with the adding and subtracting. Okay, so let's ask ourselves this question here. I'm going to zoom in a little bit more. Okay, so what is happening to x? It is having 9 added to it. Okay, what is the inverse operation? How do we undo that add 9? We subtract 9. And our golden rule of algebra is this: whatever we do to one side of the equal sign, we have to do to the other. Okay, so we're going to subtract 9, subtract 9. So this gives us, so 9 minus 9 is 0, all right? And we need to make sure that we're verifying that, because this is how we make mistakes in algebra. We just start slashing through things and we don't understand why. So 9 minus 9 is 0. And x plus 0 is x. And that's why we're allowed to slash through those, okay? Because it's x plus 0 cancels out that positive 9 minus 9, leaving us with x on the left side. Bring down the equal sign. And 1 minus 9 is negative 8. Okay, we box our answer, and then I'm going to do the check step in my head. So negative 8 plus 9 is the same as 9 minus 8, which is 1. Okay, so that checked out. Number 2, what's happening to x? It's being multiplied by 5. So we need to divide by 5. We really rarely use the division symbol in algebra anymore. And if you look at the division symbol itself, it's a fraction, something over something else. This dot is the numerator, that dot is the denominator. So we're dividing by 5. And whatever I do to one side of the equal sign, I have to do to the other. Okay. 5 divided by 5 is 1. So I want you to change that into a big 1. So now our coefficient of x is 1. So 1x equals 35 divided by 5 is 7. Okay, so x equals 7, or 7 equals x. Those are equivalent equations. You don't need to rewrite that. If you always like to have the x first, okay, that's fine. You can rewrite it. But you really need to start getting comfortable with seeing the variable on either side of the equal sign. And it's better to start getting used to that now while we have simple equations, okay? Because when you have a complex equation, you're not going to want to have to rewrite it so your x is on your left side, because you like that better. Okay, then, excuse me. So we're going to do our check step for 7. 5 times 7 is 35. Okay, so that checked out. Number 3, what's happening to x? It's we have 9 being subtracted from it. And so we will add 9 to each side. Whatever I do to one side, I have to do to the other. I'm looking for you to show me this step. This is the equal line. We show the equal line. It's no different than when we did that in elementary school. 2 plus 3 is 5. What's missing? We're missing our equal line. Okay, so anytime we're doing an operation, we need to make sure we have an equal line that signifies that we are finishing a step. Okay, so that's important, and I don't want you to get sloppy and skip that, because that's how you can blend your steps together and things get blurry and messy. So we will add 9 to each side. 9 plus 9 is 18. So you always want to make sure you're actually doing that operation. You're not just randomly slashing through things because you see 2 things that look similar. Okay, 9 plus 9 is 18. Add that up. Over here, negative 9 plus a positive 9 is 0. So that's a 0 pair. We can slash that out because x minus 0 is x. So our solution is x equals 18, and then we check that. We're not going to write out the check step for these simple one-step equations. Okay, so in even some of the two steps, we can check those in our head. 18 minus 9 is 9, so that checks out. Okay, number 4, what is happening to x? X is being divided by 7, so we need to multiply by 7. Whatever I do to one side, I have to do to the other. So I'm going to multiply by 7 on the right-hand side. I'm going to multiply by 7, or if you prefer, you can write 7 over 1 on the left-hand side. We're still going to do our equal line. Okay, we're going to cross cancel, okay? The 7s, if you don't cross cancel, you'll end up with 7x over 7, and then you can divide it out there. 7 divided by 7 is 1, so 1x equals, and 11 times 7 is 77, and then we'll do our check step mentally. 77 for x, 77 divided by 7 is 11, so that checks out. Number 5, we have 3/4 x equals 9. So what is happening to x? It's being multiplied by 3/4. So how do we undo that? We want to divide by 3/4. And how do we divide by 3/4? We multiply by the reciprocal. Okay, how do we divide by a fraction? We multiply by its reciprocal. So to divide by 3/4, we multiply by 4/3. Okay, and whatever I do to the right-hand side, we have to do to the left-hand side. I'm going to change my 9 to 9 over 1. I'm going to multiply by 4/3. Okay, the 4's cross cancel, the 3's cross cancel, leaving us with x. Okay, over here, the 9 and the 3 are both divisible by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So I have numerator times numerator. 3 times 4 is 12. Denominator times denominator. 1 times 1 is 1. Okay, so those were all one-step equations. We didn't have to think about what to do first, which operation to do first. So now we're going to start with some two-step equations where we do have to decide which operation needs to be done first. So remember, we're going to do PEMDAS in reverse. Okay. So is anything being added to or subtracted from our variable x? Yes, there's a minus 13. And then is anything being multiplied, is our variable being multiplied or divided by anything? Yes, it's being multiplied by 2. So minus 13, comma, times 2. So when I want to undo that, I'm going to go use that order of operations in reverse. So I'm going to add 13, and then I'm going to divide by 2. Okay. Excuse me, I'm going to get some water. All right, so then we will add our 13. Whatever I do to one side, I have to do to the other. So negative 13 plus 13 is 0. Bring down the 2x, bring down the equals. 3 plus 13 is 16. Then divide each side by 2. 2 divided by 2 is 1. So I have 1x equals 8. So x equals 8. I'm going to check that. I can do this with mental math. If x is 8, 2 times 8 is 16. 16 minus 13 is 3. Okay. Number 7. Again, PEMDAS in reverse. Okay, adding and subtracting. Is anything being added to or subtracted from our variable x? Yes, there's a plus 1, comma, and then is anything, our variable being multiplied or divided by anything? Yes, it's being multiplied by negative 4. All right. So I'm going to subtract 1 from each side and then divide by negative 4. Those are the inverse operations. Okay. So I'm working backwards in the order of operations. So adding and subtracting. Is anything being added to or subtracted from our variable? Yes, there's a plus 1. So we subtract 1. This gives us negative 4x. This negative 1 plus 1 is 0, so we're allowed to slash those out because negative 4x plus 0 is negative 4x, negative 4x. Bring down the equal sign. 31 negatives and 1 negative is 32 negatives. So negative 31, take away 1 more is negative 32. And then next we had negative 4x equals negative 32. Obviously that's our only lasting step, or only last step, but it would fall right here with the multiply and divide. So we would do it next if there were other steps as well. Negative 4 divided by negative 4. A negative divided by a negative is a positive. 4 divided by 4 is 1. So we have 1x equals. Okay, a negative divided by a negative is a positive. 32 divided by 4 is 8. So x equals 8. And then we'll do our check step. Negative 4 times 8 is negative 32. Negative 32 increased by 1 is negative 31. Okay, now when we look at number 8, we have some implied grouping symbols. So when we have the fraction bar that goes completely separates the top from the bottom, in our mind, we need to think of it this way. This is an x minus 3, and all of x minus 3 has to be divided by 2. So the entire top gets divided by the entire bottom. So that's really a set of grouping symbols, which means it is going to be undone last because it's it's parentheses. Okay, so in this problem, we're still doing the order of operations in reverse, but we need to recognize that these grouping symbols, and we'll change it to G for grouping symbols, because remember, it's not actually parentheses. That division bar, the fraction bar, functions as a grouping symbol. Okay, so that is here. That symbol right here, that division, is way back here when we're doing the order of operations in reverse. Okay, so here what is happening to x? It is being divided by 2 and increased by, or decreased by 3. So we're going to multiply by 2 and then increase by 3. So to do that, we're working order of operations in reverse. Anything being added or subtracted, yes, but it's in grouping symbols. Okay, so we need to cancel out this divide by 2 first. How do we cancel out divide by 2? We multiply by 2. Whatever I do to one side, I have to do to the other. Oops, sorry, or with the answer. Okay, these 2's will cross cancel, leaving us with x minus 3. 4 times 2 is 8. Then we add 3 to each side, and we get x equals 11. And we always box our answers. Okay, then we're going to go ahead and check that because we want to make sure we're correct. So does x equal 11? So I go to my original equation. I'm going to get rid of all the extras here. So our original equation, okay, was x. Make that a little bit more clear for us. The quantity x minus 3 over 2 equals 4. So if x is 11, 11 minus 3 is 8. 8 divided by 2 is 4. So that checks out. Okay, I'm going to put these parentheses back. And then number 9, we have 4 minus x equals negative 44. So remember that a minus functions the same as a negative, all right? If you don't like that, you can always change this. Instead of minus x, you can say plus a negative x if you like that. If you like that better, that notation better. So first of all, x is it's negative. Okay, so we need to recognize that it's a negative 1. And and then this 4 is a positive 4, so it's being increased by 4, and that's being multiplied by a negative 1. Okay, so this 4 is getting added on. So it doesn't matter if I have it first or second, it's a positive 4 being added into this equation here. All right, so you might think of it this way, negative x plus 4. See how the x is negative and the 4 is positive. Okay, so I don't want you to rewrite it this way, but do understand that these are equivalent expressions. They are equal to each other, okay? So negative x plus 4 is exactly the same thing as positive 4 minus x. You could rewrite it that way if you're really confused by this, but I prefer that you get used to seeing it in either order and recognizing that they're the same thing. Okay, so this positive 4 is here. So how do I cancel that out? I'm going to subtract 4. And then x is being multiplied by negative 1, so I want to divide by negative 1. So let's go ahead and do that. We will subtract 4 from each side. This gives us, okay, and here's where we want to make sure we're very careful, because some kids will put a plus 4 here and they see 2 4s vertically and they just draw a slash through it. No, 4 plus 4 would give you 8. Okay, so don't just get in the habit of slashing. Actually work out this little problem every time. 4 minus 4 is 0. Okay, 0 minus x is negative x. Negative 44 minus 4, so you're at negative 44. You take away 4 more, now you're at negative 48. Okay, now I'm going to tell you just what I say in my head when I'm working with negative variables, but then I'm going to prove it to you mathematically why it works. So if a negative x is a negative 48, then a positive x is a positive 48. And that'll always be true. And here's why algebraically, because we don't care what negative x equals, we care what x equals. So we want to cancel out that negative. Okay, so how do I cancel out the negative? I have to divide by a negative, or you can multiply by a negative. So I prefer to divide. X is being multiplied by negative 1, so we're going to divide by negative 1. Whatever I do to one side of the equal sign, I have to do to the other. Okay, so I'm going to divide by negative 1 here. A negative x divided by negative 1 is a positive x. And a negative 48 divided by a negative 1 is a positive 48. Okay, then we're going to do our check step. 4 minus 48. So if I'm at positive 4 and I take away 48, that puts me at negative 44. So that checks out. Okay, number 10. So we're again following the order of operations in reverse. Okay, so what is happening to x? Here's my x term. There's a 5 there, and it's a positive 5, so it's being increased by 5. And then here's my x term. It's being multiplied by, not 3, it's being multiplied by negative 3, okay, or minus 3. So here's my x. It's being multiplied not by 3, it's being multiplied by the opposite of 3, or negative 3. So times negative 3. So what do I need to do to solve that? I need to work backwards. Okay, I'm going to use that order of operations in reverse. So there is a plus 5. I'm going to subtract 5. There's a times negative 3. I'm going to divide by negative 3. All right, so let's go ahead and do that. Order of operations in reverse. Addition and subtraction. Is anything being added to or subtracted from our x term? Yes. There's a positive 5, so we want to subtract 5. Whatever I do to one side, I have to do to the other. Negative 4 minus 5 is negative 9. Here we have 5 minus 5, that's 0, and bring down the negative 3x. Okay, then I move on to, I'm done with addition and subtraction. Is there any multiplication or division? Yes. X is being multiplied by negative 3, so we are going to divide by negative 3. A negative divided by negative is a positive. 3 divided by 3 is 1. So negative 3 divided by negative 3 is positive 1. So I have positive 1x equals, and negative 9 divided by negative 3, negative divided by negative is a positive. 9 divided by 3 is 3. So x equals 3. Okay, so let's check. Is x negative 3? Okay, this 5 minus, then we have 3 times 3. So 3 times 3 is 9. 5 minus 9 is negative 4. Negative 4 equals negative 4. So that all checks out. Okay. When we get to more difficult multi-step equations, especially when we have, when we get to more difficult multi-step equations, I will require you to show your check step. And so what I'll ask you to do is write the original equation, negative 4 equals 5 minus 3, and then where the x was, substitute in your answer, then continue solving. 3 times 3 is 9, so this would be 5 minus 9. Bring down the negative 4 equals, and then 5 minus 9 will be negative 4. And then once you end up with a true statement at the end, negative 4 equals negative 4, you know you've solved it correctly. So this check mark signifies to me where you started your check step, and this check mark signifies to me where you finished your check step. Okay. Okay, 11, we have x plus 6 divided by 5 equals 10. So again, we have this understood grouping symbol with this fraction division bar. Okay, so we're going to follow our order of operations in reverse and recognize that this is a grouping symbol. Okay, this fraction bar serves as a grouping symbol. So x is being divided by 5, so we'll multiply by 5. And then x is being increased by 6, so we will decrease by 6 when we're solving. Okay, so again, we need to, there's no addition or subtraction outside of the parentheses. So this step we don't have. So then we move on to the multiplication and division. Our quantity x plus 6 is being divided by 5, so we need to multiply by 5. Whatever I do to one side, I have to do to the other. A 5 in the numerator cancels out a 5 in the denominator when we just have two things multiplied together, this quantity times 5, okay? So then we simplify, we have x plus 6 equals 50, and then we subtract 6 from each side to get x equals 44, and then we will check our answer. 44 plus 6 is 50. 50 divided by 5 equals 10. Okay, so that checks out. Okay, number 12, a little bit simpler. We don't have that whole implied grouping symbol here with the numerator separating the denominator. So we have, is there any adding or subtracting? Yes, there's a minus 9. And then is there any multiplying or dividing? Yes, there's a divide by 8. So we will add 9 and then multiply by 8. All right, and then with this is like that mental process that I go through, but you'll get to the point after this lesson where you don't need to write those down. So is anything being added to or subtracted from our variable term? This is our variable term because the x is over 8 right now. Yes, there's a minus 9, so we will add 9. Whatever I do to one side, I have to do to the other. This is showing your work. Okay. And when you are doing your tests and quizzes, if I see the work and I see, oh, this was an obvious arithmetic error, you know, they said 4 plus 5 is 10, and I know that they know 4 plus 5 is 9, or what, not in this problem, but so if you're showing your work, I can see that. If your only error was an arithmetic error, I'm probably not going to count that against you unless you're making multiple errors, okay? So it's really important that you get into the habit of showing your work, not only so that you get points for your tests and quizzes, but also because as we get to more complex equations, you need to develop these habits from the beginning of how to show your work and how to balance equations while we're working with simple equations before they get complex, okay? Because they do get complex quickly. And then 9 minus 5 is 4. Over here we have x over 8. So x is being divided by 8. So we need to multiply by 8. Whatever I do to one side, I have to do to the other. Those 8s cross cancel. Okay, so we have 32. X equals 32. And then we have explained each step in solving a simple equation as following from the equality of numbers asserted in the previous step, starting from the assumption that the original equation has a solution. Construct a viable argument to justify. So can we explain each step and justify the method, and then explain how to solve the equation using complete sentences and proper verbiage in your explanations. So we're just basically subtracting 8 from each side, because we're trying to isolate the variable. So to isolate the variable, follow the order of operations. And then I just abbreviate it. You're welcome to abbreviate it, order of operations, okay? Follow the order of operations in reverse. Okay, so really what we're doing is add 8 to each side. Oh, sorry, subtract 8 from each side, excuse me. And then when you're actually doing that calculation in your head, like I just looked at my paper and said, oh, 8 plus 8 is 16. Okay, so we need to subtract 8 from each side. So when you're doing that, instead of just slashing them out and you're actually mentally checking that arithmetic, you'll catch little errors like that, okay? So we're going to subtract 8 from each side, okay? So 8 minus 8 is 0. 17 minus 8 is 9, okay? So here, to follow the order of operations in reverse, we will add 5 to each side, then multiply by 3. And then multiply by 3. Okay, so add 5, add 5. This gives us x over 3 equals 6. Okay, then multiply each side by 3. That gives us x equals 18. Okay, that's just not, let me readjust my camera, sorry. All right, there we are. A farmer knows that his rectangular land, so as soon as I'm a visual person, so as soon as I see the word rectangular, I'm just going to draw a rectangle. And so when I see farmer, I'm just thinking of a garden or a plot of land. So the area is 10,000 square feet. And then in my mind, I immediately say, hey, I know the area of a rectangle is equal to length times width. Okay, so I'm going to write that down. The width of the land is 2,000 feet. Okay, this, what we would normally refer to as an apostrophe is feet, okay? And when you have two of those, like a quotation mark, that's the abbreviation for inches in math. The equation that represents this situation is 10,000 equals 2,000 L. Okay, we divide each side by 2,000 to get L. So 10,000 divided by 2,000 is proportional to 10 divided by 2, okay? 10,000 divided by 2,000 is proportional to 10 divided by 2, and 10 divided by 2 is 5. So 10,000 divided by 2,000 is 5. Okay, so it's proportional. 2,000 divided by 2,000 is 1, so you can just change that into a big 1. Okay, so the length would equal 5. Okay, so my way off scale there. So it should have been the rectangle the other way, but that's okay. It was just a visual aid. It's not an art project, it's a learning tool. So that's out of scale. Okay, so we can't always trust our math drawings to be to scale. We always have to trust the numbers. L equals 5. Okay, so maybe they just had like this long strip of land along a road and they just decided to go ahead and make use of that rather than let it go to waste. You make an Amazon order under your parent's name and you order some fun socks for yourself. The total for the order was $51. Shipping was $12 and each pair of socks was $3. The equation that represents the situation is $51 total equals $3 per pair of socks S plus the $12 shipping fee. Find out how many pairs of socks were purchased. So $51 total, 3 pairs of socks. And when I'm reading S's in cursive or in algebra, sometimes I like to write them in cursive because especially if I'm writing sloppy, I don't want my S to look like a 5. And then we also tend to, not always, in geometry it's different, we also tend to use lowercase letters in math so they're not capitalized and the full height of numbers. Okay, so that helps us to, doesn't completely eliminate when we make mistakes with our writing in our notation. So we're pretty specific as mathematicians on the notation that we decide to use for our problems. Okay, then we add 12 to each side. Okay, and then 51 minus 12 is 39. Okay, divide each side by, this slashes out, divide each side by 3. Okay, 3 and 1, so we get 13 pairs of socks. Okay, so 13 pairs of socks were purchased. On Canvas, when we're working, normally I'm really specific about putting in the units, but in Canvas, you can just write in the number, the numerical value, okay? Because it's not really great at recognizing words and written things. So 13 is our answer. Okay, pairs of socks. And then tonight's homework is solving one-step and two-step equations with justifying practice A, which is a front and a back, and then also justifying or solving 1 and 2 step equations practice B, and that's also a front and back. It'll be a 4-page document that you turn in. And that is solving 1 and 2 step equations.